Thank you, Jeff. Unfortunately, we won't have time for questions. Let's move the morning to the next session. The next session will be a panel discussion titled Quantum for Industry. We'll have the opportunity to interact with the House representative, the Honorable Greg Bonnen, and then we'll have representative from D-Wave, NVIDIA, UT Austin, and HPE Quantum, and IonQ.
Hello, everyone. My name is Rashmi Varma, and I'm the managing partner at VAJR Capital, as well as the CEO of a research lab based out of Richardson, Texas, called QuantaWatt. I have worked for the past 2 decades at the intersection of quantum photonics, advanced wireless networks, and digital infrastructure. And typically, my projects involve a lot of technical fluency, entrepreneurial agility, and systems level thinking. And for that has brought me here to the Texas Quantum Summit today. And I am honored to lead this panel. Very quickly, let me So the panel here today focuses on opportunities and challenges for applying quantum computing across industries in Texas. Questions are designed to span policy, research, industry adoption, and practical applications. And we will have some time for questions at the end of the panel. Let me introduce my panelists here. We have Honorable Greg Bonnen from the Texas House of Representatives. We have Yasalde Jiménez Acosta from D-Wave, Yuri Alexeev from NVIDIA, and Srinivas Bettadpur from NASA Quantum Pathways Institute at UT Austin, Marco Pistoia from IonQ, and Gerald Kleyn from HPE. With that, I ask my quantum panelists here to introduce themselves as well, starting with Greg Bonnen.
Well, thank you. It's an honor to be with you guys today, and thanks for serving as moderator. I understand you got called in on short notice, so we have the relief pitcher here. My name is Greg Bonnen. I'm a member of the Texas House of Representatives. I work mostly on the budget, so that's my main responsibility in the House. And in recent years, I've had an opportunity to work on some other really important areas in our state, and that would include semiconductors and space. And I'm honored to be here to talk about quantum and how that's going to interface with some of the other big things that we're investing in Texas.
Good morning. My name is Yasalde Jiménez. I'm just delighted to be here representing D-Wave, and thank you for the invitation from everyone from the summit we're involved here. At D-Wave, so I'm the head of academics or higher education and research lab partnerships and engagements, so really kind of playing the bridge between D-Wave and academic institutions that want to either pursue research on our platform or want to also deliver more commercial applications on our platform. Really looking forward to an engaging conversation and just really happy to be here.
Good morning. My name is Yuri Alexeev. I'm a senior quantum algorithm engineer at NVIDIA. I develop quantum algorithms using CUDA-Q. So you'll hear a lot from me about CUDA-Q. It's a platform. It's a hybrid, heterogeneous environment that supports QPU, GPUs, and CPUs. It's modality agnostic. It has a native support for intranode and multi-node parallelism. It also provides state-of-the-art quantum circuit simulators, libraries, and so on. CUDA-Q is open source and actively welcome external collaborations. And I'm going to talk a lot more about, as I said, in my answers here about CUDA-Q.
Thank you very much for this opportunity. My name is Srinivas Bettadpur. I'm faculty in the Department of Aerospace Engineering and in Engineering Mechanics. I'm also with the Center for Space Research at UT Austin, which is a Center for Spaceflight and Remote Sensing Research. And I will end up being somewhat of a misfit, you will see, at the end of the hour. Hopefully, let us see if I can add value by providing the pull for quantum sensing from the applications standpoint To be clear, I started learning quantum mechanics 3 years ago when I wrote the proposal for the Quantum Pathways Institute. We are well able to connect quantum sensing architectures and other sensing to the societal applications in the aerospace enterprise. The Quantum Pathways Institute includes atomic physics, systems engineering, and photonics, with the eventual goal of putting quantum sensing into space. The QPI is a NASA Space Technology Mission Directorate funded 5-year, $15 million effort tasked to take quantum sensing instrument to TRL3+ in 5 years. It's motivated by the water cycle and water resource measurement at high resolution and high accuracies, and other applications include navigation and planetary exploration. For aerospace mobility as well, one of my intents is to build a sandbox where the industry, research, and educational institutions can get together for exploring ideas. Thank you.
Good morning, everyone. My name is Marco Pistoia. I am a Senior Vice President of Industry Relations at IonQ. I am a mathematician by training. I have a PhD in math from New York University. And I've been with IonQ for exactly 2 months, actually. Tomorrow it's going to be 2 months. And what I'm responsible for is quantum computing algorithms for financial applications and quantum key distribution. So it's very exciting to work for a company that has the entire quantum spectrum, not only quantum computing with the addition of Oxford Ionics now, and a great roadmap for scalability, but also quantum networking and quantum key distribution for additional quantum computing capabilities and scalability, but also for security, and quantum sensing now. Before joining IonQ, I was the global head of applied research for JP Morgan, where I was there for five and a half years. I built a team of 102 people, and we wrote a lot of algorithms and scientific papers, many in collaboration with Yuri Alexeev here, on quantum computing for finance. And one of these papers was actually a Nature paper that was published in April of this year, proving literally quantum supremacy, so the ability for a real application, the ability to run an application on a quantum computer that would not be executable on a classical computer, and something that is actually usable in production. And before joining JP Morgan, I was for 24 years at the IBM Thomas J. Watson Research Center in Yorktown Heights, New York, where I was working also on quantum computing for algorithms and applications. Thank you.
Well, thank you. That's amazing, and I feel really honored to be here on this panel, to be amongst such a star. I'm actually quite starstruck right now. I'll start with my first question with Honorable Greg Bonnen here. Texas has long been a leader in energy, aerospace, and technology. How do you see state policy shaping the adoption of quantum computing in these industries?
Yeah, there's no question that that this is a focus of the state of Texas, is to make sure that in the technologies that are going to shape the world in the 21st century, we want to be the leader. And that's really important for our country and for the free world. And I described it to someone just a few minutes ago, is if you think about a high school volleyball team or a football team where there's one kid that maybe is taller and more athletic than the rest, it's not good enough for that kid just to be the best athlete on the team. For the team to be the very best that it can be, we need that kid performing the very best that it can perform. And that's our state. With over 30 million people, with the huge geography, with the resources that we have, with the infrastructure that's already in place, we really are in a position to shape the future. And with such an amazing panel, I'm going to kind of cut to a bottom line for you real quick, because I want to make sure that you guys think about what I'm about to say. The way that quantum computing is going to change the world is going to necessarily be multidisciplinary, right? It won't just be about quantum. So take a step back for a minute and listen to this. The state of Texas is the second largest funder of cancer research in the United States after the NIH. $3 billion every 10 years. So that's $300 million a year. Starting January the 1st, we've committed another $3 billion for dementia and Parkinson's research, so Alzheimer's, neurodegenerative diseases. We have invested $1.4 billion in semiconductors, another $10 billion into our energy infrastructure, $1 billion every year for the next 20 years for water development. Space, which I could easily forget, but that's kind of like one of my favorite areas, another $650 million just in the last 3 years. Advanced nuclear technology, small modular reactors. So why am I saying this? In the state of Texas, every single year, you've got $700 to $800 million that you can compete for if you have a strategic partner, which you necessarily will need. So if your solutions are going to be allowing us to do modeling on in a complex way that conventional computing can't, so that we can look at molecular design or other types of systems that we want to analyze. If that's in oncology, then you need to get your partner in oncology. If it's related to space applications, if it's related to neuroscience or neurodegenerative diseases, you have an opportunity to be a part of that, and that $700 to $800 million a year that's already it's already allocated. It's not a commitment. That is actually done. Then on top of that, we did, as you guys have referenced, set up a quantum initiative for the state, and that will hopefully involve bringing together some of the best minds in the world to come up with a strategic plan for Texas that's going to inform how we make more direct investment, whether it's in infrastructure or workforce or grants and other supports for industry with respect to quantum itself. But know that apart from just quantum, you have billions of dollars that the state is investing that you will actually be a part of because of the way you're going to impact these other areas of research and development.
Thank you, Greg. Dr. Yasalde, maybe the next question to you. You guys are the leaders in quantum annealing, and a lot of optimization analysis has gone through your systems. What do you think are the state incentives that will help you kind of come to Texas or expand here in Texas?
Great question. First, we love to be here and partner with you starting effectively today. So a little bit about D-Wave. For those of you who haven't heard of D-Wave before, is we've been around since the 90s, one of the pioneers of quantum computing. It's different other partners and providers design their architectures more following the gate model approach. D-Wave decided to pursue double down on quantum annealing, and quantum annealing is especially good at solving business optimization problems. Think about you have a specific budget and you're thinking of building a house, and so quantum annealing looks at all sorts of combinations to make sure that you sort of arrive to the ideal state or the ideal solution that works for you. And so it is especially good for solving those business problems today. And these are problems that are around, think of scheduling. So if you have a large retailer, hundreds of stores, thousands of employees, how do you optimize your scheduling? Think of logistics. You have a supply chain management distribution. You have lots of variables, constraints, weather, size of trucks, weight of equipment. So it really looks at those kinds of challenges. And then material design is another big area that is a focus. And what matters from a research side, it's really a strong, robust platform to engage in research and pursue research using this our Advantage system that has over 5,000 qubits, which allows you to do a lot more complex mathematical problems. For commercial partners, we have over 100 customers already using quantum or quantum platform to derive those optimization problems. I'm an information systems person, so I think of it as how do I reduce my costs and how do I improve my gross margin, my revenue. So that's really some of the ways in which our commercial customers and partners are leveraging D-Wave today. For faculty students, we're really working super hard to facilitate access of D-Wave so that faculty members who want to teach quantum computing in the classroom, we can facilitate that access and start leveraging quantum computing in your classrooms today. Research, we've seen a ton of research papers on science, nature, and we've seen a kind of a growth trajectory of research in annealing, significant growth. And so, going back to your question, it's important to I think to have that sponsorship from the institution, having the funds available to really fund some of these projects. And really the appetite or the ounce of curiosity to start experimenting with these tools. So kind of long-winded answer to say we're ready. We're absolutely going to be investing a lot of our time in this great state of Texas.
Thank you. Appreciate that answer. Maybe I'll point that question to Yuri also on behalf of NVIDIA. You guys are leading the GPU acceleration market. Actually, you're killing the market. With your work in quantum simulation now, where your GPU systems are being used, how do you see you guys expanding in Texas in those areas in the energy space, aerospace industries, and what state incentives do you think would likely bring you guys to a bigger expansion here in the state of Texas?
Yes, there are many ways how NVIDIA can contribute here. But first of all, let me give you like a perspective where we are. We are at a very interesting stage right now in quantum industry. Is that as quantum computing industry matures, quantum computers essentially now becoming more and more powerful, and at some point we become actually will become useful, and we'll be able to actually execute useful algorithms, because we are not developing quantum computers for the sake of developing quantum computers, right? At the end of the day, you want to use them to solve grand challenge problems. That could be grand challenge problems in energy, materials, manufacturing, or finances. This is what we work with JP Morgan in the past. So these are very exciting. So how to achieve that? So first of all, there are a few components here. You need a quantum computer, but first of all, you need actual programming environment for the quantum computer to run it efficiently. So we developed CUDA-Q. So CUDA-Q is what makes CUDA-Q somewhat unique is that it is QPU agnostic, modality agnostic. We are not tied up to any particular vendor. We support all vendors. And in fact, we actually want to succeed all vendors. So this is kind of like a general kind of like a motto, philosophy behind NVIDIA. So that's one side. So you have a quantum computer, you have a programming environment, and we also need environment where actually you design quantum algorithms as well, because these quantum computers right now, for example, they are quite expensive. It can be hard to get. What you need to do, you need to have a virtual environment where basically you want to design these algorithms, test them, benchmark them, and actually prepare them for deployment. So for that, what you need to have quantum circuit simulators. Think about this as a kind of like virtual environment. So what you do, you basically develop all these different algorithms like in energy, materials, and manufacturing, as I said, test them. And after that, in this environment, we have very, very seamless transition. All we need to do, for example, is going from our environment, from this virtual environment, to executing on the actual quantum QPUs on quantum processor is just a simple switch to the back end. I guess that's the message what I wanted to say. Okay?
All right, thank you. Thank you, Yuri. Maybe I'll move to Dr. Pistoia next. Same question. With IonQ, we heard from IonQ, from Philip Farah earlier, all these acquisitions you guys are making globally and expanding IonQ, or in computing, networking, sensing. I mean, you have the whole gamut there. What will make you guys come into the state of Texas? What state incentives would actually help you expand here?
So I think Texas is like the perfect state in the United States where quantum computing can have big impacts. So we actually studied geographically speaking, we studied some of the counties inside Texas, and we understood that, for example, this could be the first territories in the US, like terrestrial locations where QKD, quantum key distribution, could be deployed. So we know that quantum key distribution is something that acts at the network layer of the TCP/IP stack, at the physical layer. So you can secure entire communications without even having to touch code. There is a limitation in terms of distance. You can, the two QKD boxes, the two endpoints have to be within like 100, maybe 175 kilometers with each other, even though at this point this limitation is about to be completely overcome, thanks to technology owned by IonQ, particularly quantum memory, which is something that we are getting from LightSync, one of our acquisitions. Quantum memory is the foundation for quantum repeaters, which allow for extending the range of quantum key distribution networks. And for things that are too far away from each other or that have to cross the ocean, you can use satellites, which is something that has already been proven. It's not like science fiction. This is something that we can also support thanks to the acquisition of Capella Space. So for whatever reason, the United States invented quantum key distribution in 1984, but it's not capitalizing on this invention. Other countries are much more advanced. China and Russia, for example, are already connected using QKD. China has the longest quantum key distribution network in the world, 4,600 kilometers. So we need to start somewhere, and I believe Texas, with its geographic configuration, is the ideal state to start with terrestrial quantum key distribution and then evolve it into a connection that can involve satellites, and start from Texas, the entire country can follow. Now, going back into quantum computing, I think again, Texas is already a leader in many ways. We have great universities here. I mentioned before a Nature paper that we wrote at JP Morgan Chase. Yuri was a co-author. Professor Scott Aronson from University of Texas at Austin was a co-author. So I think we need to start bringing quantum computing, even in the high schools, in my opinion, as a subject for initial learning. So with the presence of IonQ, for example, can deliver quantum computers to the States for early education. We don't have to wait for people being in a PhD to start learning and working on quantum computing. I actually know high school students that are already writing papers in quantum computing. They are really good. I mean, publishable material. So this is not something that is out of question. So for advanced programs, this is something that could be done. And quantum computing can help, obviously, financial institutions. I say obviously because that's where I come from, and I know that it's the ideal industry domain for quantum, given the richness, the abundance of use cases, and the fact that in finance, time is of the essence. Everything has to be solved in real time. So financial institutions, but also logistics. For example, there are so many companies in Texas for oil extraction. There are a lot of optimization use cases that can benefit from quantum computing. And so I think there is an incredible opportunity for the states to leverage the quantum field.
Thank you. Appreciate that answer. Dr. Srinivas, no mistake in inviting you here. I think you will have the most remarkable contribution to this panel after I ask you this question. NASA is deeply invested in quantum pathways. What opportunities exist for Texas-based quantum companies to collaborate with NASA on quantum initiatives?
Thanks. So I won't pretend to speak for NASA clearly. NASA has signaled, if you just read the newspapers, trade journals, and attend the conferences for about 10, 15 years, that they're more and more willing to outsource end-to-end sensing measurements functions as opposed to procuring parts or procuring capabilities. Ever larger pieces of the enterprise can be outsourced. That has been very clear. The trend has been clear for 10 to 15 years. And so there, partnership between industry and academia, for example, can actually accelerate the role of the industry in soliciting those opportunities for executing the functions at the national level. And we have examples in this room of companies that are participating in executing the function for NASA. And so that's been true in conventional industry forever, right? And for quantum, I think with the piece that is missing, at least from my perspective, is the user community. So this community here is largely physicists and electrical engineers, right? What you want is that this room to be filled with people from oil exploration companies, from earth science resources communities. They are the ones for whom entities such as NASA are actually executing the missions. And so they need to be the third entity present in the room in the large numbers. And I think that will be an important part of ensuring that everyone is engaged in executing the national mission. Right? So I hope that is...
No, that is excellent. I like your point that the end users, like oil and gas, they need to be in the room here to understand how they can use quantum initiative towards themselves as well. And that's a very good point. Thank you so much. I'll come back to Honorable Greg Bonnen here. Since he said, there has to be an ecosystem, right? Of physicists, electrical engineers, your end users, your quantum companies. I won't leave the high school students out because a lot of folks are talking about K-12 education here in quantum physics and such. All in all, I guess workforce development. But is there an opportunity for us to build something like a quantum corridor here in the state of Texas, similar to what we've done with semiconductor industry?
So obviously the answer would be yes. Now, having said that, I would tell you those things to some extent happen organically. In other words, people go where the opportunity is, where the expertise and the resources exist. So I don't want to say we just created a semiconductor corridor, but so by day, they tell you being a state representative is a part-time job. Okay, don't believe them when they say that. My day job is I'm a neurosurgeon. So my chief of neurosurgery when I was in residence used to say, Greg, fortune favors a prepared mind. There's no such thing as like fortune favors a prepared mind. And so we can talk about creating a corridor, but really we create the fertile ground and then the corridor will, it will eventually come around. So if you're prepared, if you're a good Boy Scout, then I think that will happen. Academia is a key partner for us in Texas, and there are a number of reasons for that. And I have to point out, so you have the chair of the House Budget Committee, but you also have Terry Wilson, the chair of the Higher Education Committee, is here with us in the room today. He and I were classmates here at A&M in 1988. I don't think we were running around as students on this campus. We ever would have dreamed sitting here talking about quantum initiatives in the state of Texas. I don't think our professors would have believed we'd be sitting here talking about this either. But here we are. We find that bringing all of these stakeholders together through higher education is often the very best opportunity that we've got. And that includes K through 12, by the way. And we've done that with a lot of space education and initiatives. They can reach down into that level. They're good for workforce development. They're good for industry partners. But from a fiscal perspective, they're, in most instances, we're talking in Texas about public institutions. So they're accountable to the public. They're accountable to the taxpayer through their representatives, which makes it easier for us to make major investments, and then they can collaborate with industry and collaborate with K through 12 and bring that all together. So I think the short answer is yes, we can certainly do that. And I'll close by saying this. A pet idea of mine is that the funding that you receive will be directly proportionate to the quality of your proposal and your plan. So to the extent that you have a really well thought out strategic plan that resonates, it makes sense, you've done your due diligence, you've done your homework, then we're in terms of wanting to make investments in that. And so don't hesitate to reach out to us and say, hey, I've got a great idea. This is what it looks like, and this is the opportunity that I see for the state.
Thank you. Appreciate that. Do any one of you have a comment on the creation of quantum corridors? I mean, something similar to what Chicago is doing. I think there are probably lessons to be learned there, lessons to be transferred. Any comments from any of the panelists about a Texas-based quantum corridor?
Yeah, I'll chime in. So one example that comes to mind is we recently partnered with a German supercomputing center, Jülich, and it was an interesting, really use case that they essentially had a massive supercomputing center with a cluster of large, very powerful computers. And they recently invested in one of our quantum computers simply because they wanted to establish kind of a hub and spoke innovation center where they are really partnering with not just the academic institutions but also the industry. And so what they're trying to do is create that hub and spoke where researchers will come in with strategic proposals and they want to fundamentally do research on the platform, but they can also provide access to students, researchers, faculty, as well as other maybe entrepreneurs that want to maybe solve business problems with the same computational sort of ecosystem that they built. So something like that I'm seeing more and more in the US. We have a similar scenario in New Mexico where there's a consortium. Someone is really kind of holding the purse, if you will, but there's almost creates a solid, healthy competition within the ecosystem, all trying to acquire resources for them to push research or do experimentations on the platform. So I can certainly see something like that in the state of Texas, where you have sort of that innovation hub, where it really kind of mobilizes or creates an ecosystem of students, partners, other collaborators, integrating in net new startups and things like that. So I certainly see that as a major opportunity.
So if I could take a moment, so there is analog to that in Texas as well, with the Texas Advanced Computing Center, one of the world-leading computational science facility. And the nice thing is actually I think we have a very good and very strong computational sciences, computational engineering ecosystem in Texas. And so the facilities with the mindset of using I found actually that it's not that common for people to accept or to utilize computational engineering to the extent it could be utilized for the purposes of design. And you're seeing a lot of that in pharmaceutical design and biomedical research, for example. But I think that can be opened up a lot more. And I think there's a real opportunity there. I won't speak for the device, the experts here who can speak more to the devices and their applications, but from the other end of it, from the user standpoint, I think there is very much an opportunity for melding the existing leadership class performing computing facilities that are in Texas and the computational engineering infrastructure and ecosystem that's there with the large-scale problems that have been talked about. So I think that ground is totally fertile, I would say.
Thank you. I'll open this next question for the entire panel, if anyone could answer that. If you would advise a Texas startup founder today, where should they focus their efforts in the quantum ecosystem? And I know Dr. Yasalde mentioned supply chain. You know, we have a lot of quantum leaders in here in terms of IonQ, Q-era, Inflection, D-Wave, NVIDIA. But what are the building blocks that kind of make this whole quantum ecosystem successful? Where would you advise, startups that want to come into quantum space? Where should they really focus?
can I
Yeah,
answer?
go ahead.
So I think quantum offers a lot of new opportunities for startups. So there can be two types, I guess. So quantum companies or quantum users. So I think we can, at this point, categorize companies that want to join the quantum momentum under these two domains, like companies that basically want to provide quantum value, and so this can be quantum hardware companies, but that obviously requires a lot of knowledge and investment, but also users of quantum computing. And so definitely quantum is opening up a lot of new job opportunities and a lot of new commercial opportunities as well. And when it comes to being a quantum provider, there are not just quantum hardware companies. So there are companies that can work at the level of algorithms, applications, or even software, user interface, educational material. So I see a lot of this already happening in sporadic situations, but it can become much more active. And then there can be companies that don't want to actually build quantum computing solutions from scratch, but they want to use quantum as a resource. So for this to happen, quantum has to be modularized and offered. So for example, quantum algorithms have to be offered as libraries. And so it's almost like what's happening with AI/ML. At this point, companies can use AI/ML without being necessarily companies that write AI/ML algorithms. So eventually the same type of democratization, can happen for quantum, where people can assemble quantum components without having to build them from scratch and provide solutions for their own companies or other companies.
Thank you. Thank you. Anyone else?
Yes, maybe I'll say a few words. So, first of all, operation of quantum computers does not happen in isolation. So, when you operate a quantum computer, it requires substantial classical resources as well. So what kind of resources? First of all, you need pre-processing. So I'm talking about, let's say, compilation, which is, by the way, it's an optimization task, a very hard optimization task. Also runtime, it's a quantum error correction, quantum control tasks, or post-processing, for example, error mitigation. And HPC plays very, very important role. Why it is? Because it's very interesting is that when you take a quantum computer, classical, as you scale up quantum device and you increase number of qubits, you can envision very easily a case when actually bottleneck becomes classical parts. Because quantum is actually fundamentally, when you try to solve quantum problems, right, it's actually designed to solve them. Classical requires, many of these classical problems require exponential resources. And they are trying to solve very hard problems. So the question is how to approach this. One way is to use high performance computing, so using GPUs, for example, and using very efficient technologies that exist. Another one is that we can use AI and machine learning. And when you're talking about AI, there are different flavors of AI, basically. And I'm talking about, for example, generative AI. This is kind of like my favorite. This requires also kind of like, this is for solving this type of problems, it's a very interesting approach because it requires massive amount of pre-training, but the solution itself is instant because inference is basically it's instant. Like for example, ChatGPT, pre-training can take like years, right? But it gives you an answer instantly. So the same actual approach can be applied here for quantum computers. And my point is that using GPU technology, HPC, and AI can be one way solution how we scale up these quantum devices to thousands, if not millions of qubits. And that's actually the key to make these quantum devices useful. And I think there are many opportunities here because as we actually going to scale up this technology, there will be a lot of bottlenecks. And a lot of bottlenecks, I would say, not only the quantum side, and this is where actually industry focuses right now, but I believe very soon there will be a lot of bottlenecks also on the classical side, and there also be lots of opportunities there.
Okay, thank you. Anyone else?
Yeah, I love what you said, Dr. Yuri, and I think if I was to maybe advise for entrepreneurs you mentioned, would be really building that fluency between classical GPU, QPU, because ultimately these are tools that are going to help you solve a problem or a series of problems. So really having the diversity of these different tools right under your belt, so really building that fluency if you're thinking about launching a startup, because quantum isn't really going to replace QPUs or classical. It's just another tool set within your toolbox. And secondly is the starting. Feel more of a practical person, IS background. So what is the problem that we're trying to solve? And so we're thinking about energy, climate, just really normal day-to-day resources. Finding those large, costly problems that we can solve together, not just with quantum, but with classical QPUs, and then really start with what is the ROI? What are the fundamental problems that we should be thinking about solving today with a series of tools that we have in our fingertips. So thinking about the ROI, think about what specific problems we're trying to solve, and then go after those. And I think that's a really niche, interesting gap in the startup world.
Yeah. And that was fantastic, because that's exactly what I was channeling, kind of where I was going in the beginning when I said, hey, the state of Texas is over a decade going to invest $8.5 billion easily in research. And we've actually identified somewhat specifically, I mean, cancer is a broad area, neurodegenerative diseases is broad, but it gives you some idea. So the point being, if you're an entrepreneur and you're not just looking at the technology, but at the end game, where you're going to create value, you're going to be much more interesting to investors and to people who want to come and help you solve that big problem. So that was beautifully said. I think, to me, that's how you really create momentum and engagement, is not only just looking at what the technology itself can do and what the problems are, but where are we going and what problem are we going to solve? And that's going to create huge opportunity.
Oh, that's awesome. That was actually sublime. That was the most sublime message I've heard. It's about the end game. It's about solving the problems with whatever technology is available to us today. That's what we should be focusing on. That's awesome. I'm going to open this up to questions from the audience. I know a lot of you guys have questions. Dr. Michael?
Hi. My question to you is, what do you as industry people want more from us academics and the students we produce and the kind of output? And what do you see as your role in helping us get that to you?
So maybe I'll answer this question. So it would be good to be more aligned because you guys are building the foundation of the future workforce. So the industry can provide the use cases because many times, for example, even when I was getting my PhD, I didn't know what use cases to solve, so I probably solved useless problems in a sense because nobody told me what the real problems were. So it would be good to have an alignment, and so a good partnership between industry and academia can be a source of use cases that can inspire the research done in the academia, and so the students are already solving real problems and they're more prepared for their future jobs.
I would answer that with a response and a question. And the question I'll lead with, I won't answer, and that is that I cannot tell you how often I hear about workforce. So much so that I have told certain individuals never to use that word again, because to me it's a nebulous word. I want to know what is the workforce you're looking for, because we can incentivize our institutions to produce that workforce, but we have to know what it is. Is it PhDs in physics and electrical engineering? Is it technical skills? What is it you're exactly looking forward. So when we hear that from industry, then we actually are remarkably agile at incentivizing our educational institutions to produce that. The second observation that I would have is to go back to what we were just talking about. There's the basics of quantum, but then there's going to be having the neuro-oncologist who's quantum literate. That person's going to be hugely valuable at bridging a critical gap, right? And so it's going to be having students that graduate and maybe their area of research or expertise is not quantum per se, but they're quantum savvy. And so they understand how to interface with the industry and with what the industry can do and how to put it to use.
So actually, when you ask a question, can you introduce yourself so that they also know who's asking the question?
Sure. I'm Mike Clutch. I spoke 2 sessions ago from UT Dallas.
Yeah, okay, thank you so much.
I'm Himanshu Thapliyar from SMU Dallas. So I have a question for the panelists. For example, like Texas has some initiative on healthcare, for example, degenerative diseases or cancer. Then similarly, like quantum is also looking for applied applications. So how does the panelists see that it's like you have a quantum initiative one side and healthcare initiative on other side, how they can marry together such that both of them can benefit from the initiative that Texas is taking right now?
Sorry, I didn't mean to be flippant, but this is so close to my heart, actually. I think we have to do it. And the more of us, so okay, let me clarify, what do I mean by we? I'm an aerospace engineer, I'm not an atomic physicist, I'm not an electrical engineer. And I'm coming at this from the viewpoint of the use cases. And we have to choose to invest the time to enter into that subject. And I think if there is a job in the world that makes it easy to wander around, it's an academic's job. And so it would be a shame if we did not make use of that, right? And I think there is, the motivation for that is that, you know, there are interesting problems to be solved. There are new problems to be solved. And I think we have to ensure that our students are actually watching us take those risks and they find that normal and commonplace. I think that's at the individual human level, I think that's the most important part. So.
Thank you, Dr. Srinivas. Yeah, next question.
A general question about organization to address to the honorable representative Bonnen. What is your vision on how implementation of Texas Quantum Initiative Act will be organized on the level of Texas government? There will be created one special unit responsible for that, or each major commercial agency like health, finance, and others will be delegated some officer which is responsible for it on board. What is your vision? How it will be organized?
Well, that's a loaded question, and it could be here for a little while. So, because I've worked with our space initiative and with semiconductors, and they're designed differently, and it's not a simple question. I don't know if y'all could hear the question. The question was, how would the state organize this initiative? And how would it be structured? Where would it reside? That's kind of what I hear you saying. And I'll try to be somewhat careful with my words here, but I love what we're doing with space. And the reason is that is an organization that has some independence or autonomy. They have got a significant amount of working capital, and we have been able to attract some of the best minds, the most experienced minds in space exploration in the world onto our commission. And I think so far it's been a really good experience for them because they are actually being heard and their input is valued and they're making a difference. The flip side of that would be more of an economic development strategy where you don't have as much expert input potentially, or it's more of an advisory role, and these are grants that are being determined maybe more by government employees. And not shockingly, I favor the former over the latter. When we were putting space and chips together, I actually had drafted legislation that would have housed them together as an independent technology initiative with different elements and would have made it more autonomous. And so this is not the first time just in the last few weeks that I've had this conversation. Because one, I think it could be more powerful. And when you bring quantum experts and industry leaders together, if they know that they really are able to take agency, they will stay engaged if they feel like their input is valued. And the second reason for maybe structuring it in this format is if you brought them together, the cross-pollination between semiconductors, space, small modular reactors, neuroscience, cancer is tremendous. Right now they're so siloed that you're not getting much, if any, of that cross-pollination. So I would prefer to see something that's a little bit more independent from, say, an existing government agency, and that is combined with the other advanced technology initiatives that we have that brings the leading minds in the state together to work together on those initiatives. And then the last thing I'll throw out is we do a lot of grants, but I'm really interested in looking at other types of collaborations or partnerships because I think there can be more of an incentive and there can be a return back to the state, which allows us to reallocate that capital and not have to keep going back to the well. And I'll leave it at that.
Thank you. Yes, you can go next.
Vlad Yakovlev, Texas A&M. So I think it's a great panel to ask this question. So what is the consensus on the total quantum market for the state of Texas? So I tried to Google this answer. Also, two numbers that I got is that the current quantum technology market is estimated at around 1.5 billion globally, and for 2040, I think Boston Consulting Group put it at the top of 800 billion. Okay, also, but this is all globally. So what about the state of Texas, and is there a consensus where we want to be?
Thank you. Anybody wants to take the numbers?
Yeah. When you find the answer, let me know. McKinsey and others, they do these really bold statements. They make these bold statements, and it's hard to tell. I think yesterday there was a presenter that mentioned Japan invested 7.5 billion alone this year. U.S. coming third or second in 3-4 billion. China is leading the pack in terms of investments in quantum. But it's hard to tell which part of quantum. Is it talking sensing, quantum computing, or on the network side communication? So it's very difficult to tell. I'd love to at some point have more clarity on that, because that also allows us to figure out how we resource ourselves and how we kind of serve the market based on the total addressable market. And so long answer to say I don't know what the time is.
Thank you. Maybe we can go to the next question.
Hi, my name is Sung Wan Yoon. I'm a faculty from the College of Education, and I collaborated with quantum faculty last year for NRC grant. And I just wanted to share, like when it comes to every grant requires evaluation and workforce component. But from my perspective, I want to see more collaboration among engineering, business, and College of Education, social science. When it comes to whether designing, developing a curriculum, it's hard to really have ongoing communication from the designing phase, because over the years, such a close collaboration didn't happen for quite many reasons. And so, for example, state of Texas has the largest numbers of academic graduate programs in workforce development. Not many people know that. And College of Education has programs in learning analytics. So when it comes to whether designing an effective workforce education development systems, I see tremendous opportunities for collaborating. But when we hear the industry, government encourages and are looking for this type of grant, then such collaborations will hopefully happen more.
Thank you. Thank you for that comment. I really appreciate it. And you're right. I mean, Texas has the biggest workforce available. So it's a matter of how to collaborate and kind of bring it end to end. Thank you. Appreciate that. Yeah, next question.
So my name is Elaine Lee, professor of physics and a co-director at Texas Quantum Institute at UT Austin. I have comments and a question for Representative Bonnen. So about teaching students, I've taught a lot of pre-med students in my classes. They're the most motivated student. We just need to spark their curiosity about quantum and entice them to take another course where we'll teach them how quantum can offer the next generation MRI machine, how to image the brain, how to help them while they're conducting a neural surgery. So that's a comment. And question is, in your observation of the policymaker in the state, how likely will have a quantum analog of the CPRIT program, which is highly successful that you quoted?
Ooh. Wow. A quantum analog of CPRIT would be a big deal. So the state is on its second $3 billion commitment. It's a lot easier to gain popular support for curing cancer. But that's where I'll go back to the first thing that I said, which is you guys are going to be part of that potentially, right? I mean, this is a technology that can solve problems that we're not able to currently solve with traditional computation, number one. And number two, it can dramatically compress the timeline. So things that would have taken many years to figure out can now be solved in a dramatically shorter period of time. I think that we can make a strong commitment to quantum. I'm not going to sit here and tell you it's going to be $3 billion over the next decade.
50% is fine.
Yeah, okay, 1.5 billion. There you go. I'll have Chairman Wilson help me advocate for that. But I do want to say, as far as the medical students are concerned, I'll use my alma mater as an example. They have a combined engineering medical school program. And that may be more than what the average medical student is interested in, but even creating the opportunity for elective work in the fourth year that would introduce them to things that are synergistic to what they're learning in healthcare. But it won't be for all. Some are much more interested in just strictly being on the clinical side. Some are going to be more interested in the research or academic side. But I think that's a great observation.
Well, thank you. We are actually out of time, so I would like to thank the panel for the contribution today. This was an excellent discussion. And for those that didn't have a chance to ask the questions, I'd invite you to come and talk to the panel after they are off the stage. Thank you so much.
So as much as I don't want to be between you all and lunch, this is an important impromptu event. It won't take long. So I often half joke that 90% of what I do every day are things that I cannot talk about. And they're mostly things that are not very pleasant. Well, today I've been asked to do something that is really pleasant, and is to award one of ours for their selfless service to the quantum community. This is an award that was established by the steering committee of the Texas Quantum Summit, and I understand it's going to be a recurring award moving forward. It will be given to somebody that selflessly serviced the quantum community, and along with a plaque, there will be also an invitation for this person to give a talk at the next Quantum Summit. And as I'm reading the name on the plaque, I very much agree with this award and the committee's choice. It's somebody that I worked with over the last 2 months, and I really appreciated the selfless service. This is a distinguished quantum scientist who decided not to give a talk at this summit so that others would. And for that reason alone, she deserves the award. Olga, would you come to the podium? Thank you, Olga. You want to say a speech?
Well, just want to thank everybody who participated in this summit. So I believe that it was really a successful summit. We have in the evening a conclusive panel, and I also hope for your contribution to this panel, and the most importantly, to our final report about the summit and recommendations for the Governor Advisory Committee. Thank you.